Hello, everyone. How are you? Eyal here. It's a nice evening here, or I guess morning in some places. And what I'm trying to do is two things. First of all, I'm listening. I can't show this to you, I can't play this to you, but I'm listening to this amazing Brad Meldau album that just came out. It's called After Bach 2. After the first one is one of my favorite albums the last few years. And really what I'm doing is I'm coding a sort of a music programming language app. I know how to call it. It's like a composition system that's a little bit based on the idea. Sorry, I'll just adjust my microphone a little bit. How do I do that? Oh, I can just adjust this. Here you go. That's better. Yeah, so I think that, so I'm working on this thing in C++ here that's a music composition system. And it's built like a functional programming language. It's something that we're working on for Modalix. It's pretty raw, but I think it's exciting. At least I am very much enjoying this, and I'm hoping that I can share this with you. I'm just trying a new way to stream with this. I'm trying to do this with OBS with the green screen, kind of showing the background, and hopefully what is a nicer way where you can kind of see the code and see me blend in with the code. Then once in a while I'll make myself bigger or smaller or something, and hopefully this would make sense to whoever's watching this. Yeah, so feel free to let me know in the chat if you have questions. I am streaming this on a bunch of different platforms, like this is on Twitch, YouTube, Facebook, LinkedIn, and X, I believe. Yeah, it's kind of a weird time, I guess, to stream. It's not like what's supposed to be the good time to stream, but I am going to be enjoying this and just get into the flow. Okay, so what it is that I'm doing right now. I'm going to be, first of all, adjusting my volume a little bit. Okay. All right, so what am I doing now? This is weird, I'm trying to get used to this layout with OBS and the kind of stream chat showing in separate places. It's very interesting, How is it supposed to be looking? Okay. Okay, so here are the kind of stuff, this kind of things I'm trying to do. So what this language is trying to do eventually is it's trying to have these almost like functions, and the functions are something that the user creates, where the user will chain different devices together. Like it will take something like a repeat things that will repeat something X times, then it will pass that through a transpose, then it will pass that through a reverse, and then it will chain that with something else. So the user could create these like a set of rules or mechanisms that apply these different things in music. Now, in the implementation here, the way I've defined this, everything is what I call an expression, right? So an expression means that it's you can think about it as if, let's say, I'm just going to open just a pure C++ program, and I'll do that often. It will also help me to figure out what it is I'm doing, because a lot of things here map to not exactly to C++, but to a general concept of a programming language. So the idea is that in my code, a function is a function that has a single return statement, right? Something like int is like a return value, and the function of the user would be something like user function. It will take some amount of variables like int x, int y, right? That would be like the form of what a user function would do. And just like in code, there will be two places, or at least two, where the function shows up. One is where the actual function is written, like return x times y, like some implementation of the contents. And later, right, usually there's a call to the function that says return return user func 512 or something, right? That's usually how it's used. So in real life, you have a call to the function and you have the function itself. And when this call happens, there's some mangling of the inputs that's happening, and that's actually exactly what I'm working on, like this way to pass inputs into a function. And they did find out a few interesting things about this concept already in the implementation, which I will be going over pretty soon. So yeah, so this is how it works in C++. When in my language, obviously, I'm like let's say the user will do this in graphics. We'll see like my very, very raw graphics pretty soon. But it is that when the user will create this, the user will first of all, we'll not necessarily use something like an int. We will have like more sophisticated types. Like imagine if there was a type that's called music, right? And what this would do is actually would create something like a music object, right? Or something like the user would create some, for example, let's say you create a music and the user would sequence one after the other, or one 3 times and the other 4 times, and create like some longer form of music with this. That's really the interface of the way this program works. Like it's not a modular synthesizer that processes MIDI with notes. It processes higher level things like music. And but in terms of the interface, it's all very similar. Like my language also supports other types. Like I can do integer operations or bool operations or anything like that. And really, that's the interface that we're trying to go for. Where the user defines an operation, this operation would use both a combination of library existing operations and their own operations, and they will create a higher level function. And this is actually a concept that I will be investigating probably maybe in this stream about what it means to kind of chain functions together and express one function in form of another, and stuff that's very crucial in this kind of programming, but will also hopefully be helpful to somebody creating music and trying to express their own rules. Okay, so I'm just looking at the chat. By the way, feel free to let me know if you have any questions. I will be I'll try to monitor the chat and kind of follow along with what people are saying. There's also an experimental setup for me with this green screen blend in the background using OBS and all that. So let me know if it looks correct, if it sounds correct. I have no idea. Probably need to test, right? To go somewhere and listen to what I sound like or something. But hopefully this is good. So now that we've explained the situation, let's go to the implementation. The implementation is much less clean than anything here because I'm still figuring out all these different ways to do the implementation. So in the implementation, I might be able to put these two windows in the same screen, right? There's probably a normal way to do what I'm doing. Yeah, let's do that. Okay, this is better. Okay, that's good. Now I'm more organized. Okay, so what I found out in my last session, that wasn't a stream session, but I was making some progress myself, is that I was trying to explain to myself what does it mean to have an input to a function. And let's go back to my my raw C++ example, right? So here's something interesting about a function. Let me go back to my integer example just so that I will have this clear to myself. Okay, so when we look at a function like this here, what became clear to me is these things, in a way, even though we know that those are inputs into a function, when you look at it from the perspective of the of what's in the body of the function, those are actually outputs. What does it mean? What do I mean by that? So when the way I look at expressions here, expression, like I said, expression is something that returns a value, right? It's a set of operations, and at the end there's one singular value. Like there can be multiple. There can be multiple. There can only be one, like an int, right? A singular one. So at the end of the day, the expression, or if you think about like following expressions that what might be in the function, those expressions look at this x and y as outputs that can be connected into their inputs. So let's imagine that I would want to do something like return power of or pow xy, right? This is a function, right? A power of function. Maybe power by default is double or something, so maybe I should do something like or pow I forgot what it is. Anyway, pow. Let's imagine this works. But so I want to do a power of x and y. This function says, well, what are my when I call this function, the pow function, it says what are my inputs? My inputs are the output of x, the output of the input. This sounds so weird. The output of this and the output of y. Like these are two, sources of data that me as this function, I would be I would want to get the information from. So this is really the part that was a bit confusing to me yesterday when I was thinking about it, but I think I found a way to implement it. I'm not sure it's rock solid, so I will be testing more. But the idea is that I created something called an I/O. An I/O is an expression that has it's an expression that has an input, but this is not it. This is not the input of it, and it has a singular output. And the idea is that when I call this function, like I say, I do user function 5.8 or something. When I call this function right here, what happened is this gets binded as the output of this. Now, to make it interesting, there's something that I didn't, establish so well in my language, which is there could be multiple calls to a function, right? There could be this call, this call with 7.12. There could be this call with 15.25, right? There could be multiple calls to the same function, and I didn't test actually properly, which probably I should, that my system actually knows to bind to basically bind each invocation correctly. It's very likely that my code is not handling this situation right, because what this should mean is that this I/O thing, what I call an I/O, so these should actually be almost like duplicates. Like when this calls, there's some new invocation that gets created with a new I/O, and then x gets binded into 5, y gets binded into 8. The other invocation, x gets binded into 7, y gets bounded into 12. Like there's some binding that needs to happen so that each I/O will take their rightful input data from whoever calls them, right? One interesting thing about my language, which I guess is true for any language in this case, but it's specifically true for this one, is that all these functions are stateless. Like there's no class here that could maintain state between calls of the function. Like for example, if I had something like a struct, and I had something like a data, and here I would have something like a user function, int user function, right? Int x, int y. Then in theory, I could be modifying state here. I could do stuff like, I could have some state, and I could return x times y, but I can also keep track of how many times the function was called, right? This is legal, so that if I was using this member function, and I would do something like data user function, right? 5, 7, 9, 10. Or you know what? Let's call it again with 5, 7, 5, 7. What I could do in this function internally is say, well, I'm actually going to return I'm going to add how many times this function was called to the result, right? I can actually do that. This is legal in most languages, I guess, right? So, and then that would mean that if I would do something like cout, right? And I would call this function, and I would just do this call again and again. Let's run this. Right? You see, I get 3 different numbers. Even though I call these functions with the same arguments, this function is not pure, right? This member function is actually modifying state. It returns something else. Even if I make this function const, which I can, this will not allow me to do this, but it will definitely allow me to read from this variable, right? So in theory, I could do something like, let's say there was a timer or something, or some background process that actually adds to this. That means that still there's a chance that every time I'm reading from this, even though it's a constant function, there's a chance that I would read another state. Like, it's not pure. And what I'm trying to do is find a way so that these functions are completely stateless. Like, they get all their states from this like binding of the inputs into the body, and maybe that's it, hopefully. Okay. How's everybody doing? I'm hoping my chat is working correctly. This is my first time running this kind of a setup, so I'm hoping that this is okay. Okay, now back to the implementation. Let's see what I'm doing here. What I'm going to do, while trying to mangle all these different windows that I have. So what I'm trying to do is I want to look at this implementation that I've done. Let's look at this, what I'm doing with my console app tester. My console app tester, I was trying to kind of simulate what it looks like evaluating this kind of expression. So what I did was I created this thing called a typed graph. Basically, it's a function that returns int. And then I was in the body of the function. The body of the function is just a call to multiply. But then the inputs of the function, I think what I did here, I just bounded those directly into some variable, right? Just in a set. So I think this is just an attempt for me to set like literals directly, but I probably need to see how I can make sure that I'm setting invocation. But let's see first of all if this works. If this should basically multiply 5 and 3. Good. This is I think the multiplication of 5 and 3. So I think of what I should be doing. Now. So okay. So what I want to do is I want to be able to create multiple invocations of this, and I think I created something kind of called how do I call this? Oh, okay. But there's something else here. So when I create this creates the inputs of the function, but I don't think I have to put in values in here. I think I can just do this, not have any values. Just these are just like names. This is like X and Y, which I can also do. It's the same thing. Because currently the way I'm binding them with code, right? I'm binding the left input of multiply here and the right here. Like I'm not using these text strings. So I think that what I need to do at this point is that I should I think what I need to do here is that I should be able to start to think about what it means to do a function call. And I think, let's see what this thing, I created this thing called a function call. But I think that used the previous implementation. I probably need to rewrite this from scratch. Yeah. Whatever was there is completely meaningless. Let's rewrite whatever this is. So a function call, in this case, so let's see. It needs to say yeah, what I probably could do is I can actually, I think in this case I can probably reference in a function called the function itself. I just probably need to figure out later what does it mean to if the function gets deleted or something. But I think I should probably be able to reference the function. So I think I should do I still have this typed graph thing? Function graph. Okay. Yeah. Okay. So I think I can do as a start is I can say that I'm going to reference. Can I use a reference here? Probably not, because this, what does it mean when the actual function gets deleted? But I think for the proof of concept, I will do that. And I will find a way to notify this. So, yeah, I'll need some better way to do this. I'll need to. I guess I can use. I think I already have the concept of a map, so I think that should work. I think what I should be able to do is do something like just store the ID of the function. And I think this should work. Like this should help me to kind of do something like function graph, get function, then or maybe pointer would be good because this could also be null. So do something like if map isn't null and function is not null, right? Then return map get function. I think something like that, right? And what's the problem here? Oh, function graph. I need to just return an expression, I guess. Okay. And otherwise, just return null PTR. Okay, so this is, I think this would be like a good way to get this connection, because this this is also a way to keep testing, and if the function gets deleted, it will just do nothing. Yeah. And I think what this does, for example, what evaluate does is that if do func equals get function, then return. Oh no, this should actually do other stuff. This, let's start by doing this just as a. Yeah, I need to know which type I'm on. That's also interesting. Which type is this function? Like, can I? Because I don't think I can change this. I don't think it's legal for me to change the function of a function call. Probably any time, but I need some. I guess I need some backup, right? Instead, in case the the function gets deleted. Like I need something, I guess, or maybe not. Maybe I can. Maybe I'll need to do something else. Maybe I need to do something where, if the function gets deleted. Maybe I'll forget about it. Maybe I'll kind of assume that if the function gets deleted, then I will just not let this object exists, because what does it even mean to have a function call to something that doesn't exist? It's a good question, right? Like, because I need, because if something is if this would be still be stateful, if something is connected to this, what does that mean? What does it mean to have something connected to this value? Interesting. Anyway, let me know in the chat if you have questions about what it is that I'm doing. I will try to be to help and to give information. It's not always going to work, but I would try anyway. I know people are watching on YouTube, people are watching on Twitch, people are watching on X. I know this is a weird time for a stream, but I've decided to try anyway. Very confused about this way to stream with OBS. Okay, so what I'm doing is I want that I'm trying to find a way to create a function call, basically. And the idea is that if I have a function, I need some way to do bindings, as I said, between the into the function, what the function expects, like the arguments, and whatever's whatever is in the scope of the of this. So also I think that what should be done here. Did I create this already? Yeah, I have this thing called inputs. Inputs this and expression map, I guess. Okay. That's interesting. I'm not sure how to do this because I need basically I need inputs of this to map directly into the function. That's interesting, right? Because I need, this thing has inputs, function called, and those inputs go kind of get routed into the real function. And those inputs are connected to, like the inputs of them is connected to something external from this, like connected to something in the scope of the user. The user kind of created this, and they passed the functions in here. So I need to think. Yeah, I guess the problem I'm trying to find out is I know I can directly reference the actual function here and touch the actual function inputs. But the part that's confusing to me still, that I need to solve, I guess now, is that I need to find a way to have multiple function calls into the same thing, right? So that's going to be difficult with the way I've done it. Maybe I should change what I've done, because what I've done so far is that the function graph itself holds its inputs. Yeah, the function graph itself right now, this is the function graph. It holds this thing called the inputs, right? And the inputs is, those have singular connections attached to them. Like this thing gets its information from this source. But I'm starting to realize that this is not going to work. What I need, or at least it's not going to work with this, is where this thing. Yeah, or maybe something else that I can do is like on the fly, I could make a new connection. Like I can say, well, you're connected to this, you're connected to this. Can I do that? Like basically redo the connection before I enter the function. My language does not care about something like multi-threading, so I don't think there's a technical problem with by me changing the state here. But maybe there's another way. Maybe there's another way. The good thing about this is I can maybe I can have more concrete, I guess, connections. Another option is I can hold a vector of connection. I don't like that. I don't like that. I like the fact that the caller has all the control versus this. I like the idea that there's some interface that this function graph presents. And then the caller of the function, they can do whatever they want as long as they comply with this arrangement. So let's start with the naive implementation of this. Let's start with doing something like let's start with doing something like right here before I connect. So first of all, I need to kind of recreate. Once I create this with a function, and yeah, so once I create this with a function, which would be something like const id func2use or something. So I create this with some function, and then I would probably map is null, map get. Yeah. And then what I'd probably do is I would now, right when I do this, I should have a callback called map changed, right? That means that that I now have access to the function map. And I think at this point I should be able to create a list of inputs or a list of input pointers, I guess, that would map to the inputs of the function, right? Is that something correct? Or is another thing that I could probably do. I can probably create a special type of connection here. It's like a forwarding input. I think that's pretty good. Yeah, I can, because I have this. So I can send like let's call it a forwarding input. Inherits from input base. And forwarding input will take an input base reference, I guess, input ref to use. I would hold this as a reference, and I would kind of just and then when I initialize, oh, you know, that's interesting. I think it needs the name or something. I probably don't need to. I can probably do the name thing just as a yeah. How am I looking at the name right now? I think I'm just displaying this as is, right, as a string, a token, whatever I'm calling this. I don't love this. I probably need to do something where I do a get name. I show this with get name somehow. But I'll do something rough for now because I think this is going to need a little bit of a rewrite. But I can do something like before I'll initialize this, I'll initialize input base with ref choose.name. It's not perfect, but this could start, I guess. Okay, and to know what the type is, there's something about all these like types that I have, like int, float, different types of music types. So this would return ref get type. So this would just forward whatever the type is. And I guess what I wanted to do with this is that yeah. So I have an evaluate function here that I keep calling, whenever I'm running the language. But I think what I need to do is somehow maybe virtualize this or make this somehow so that the derived class is aware of this and can kind of inject the different behavior. Because what I need, I probably don't need to do all these connect stuff. All this stuff is kind of done by the internal thing. I just need I might just need evaluate to here you go. So this goes to the connection. But that's interesting. I can because what I need to I'm doing something more nasty. I'm actually kind of going and manipulating this thing before it gets evaluated. That's really what happens there, right? Before it gets evaluated, I go to the inputs out there and I modify it and then I evaluate it. No, I don't even need to evaluate it. No, I need to do that when the call is being evaluated. Like the call is being evaluated, I'm kind of poking into the function, changing it. I feel like this is kind of risky. I feel like there has to be a better way to do this. But I'm going to do this just because I didn't think of another way. But I feel like it's pretty horrible what I'm doing here. Yeah, I think I'll need something here. Like I would connect this, and then when I would do something like pass value or something, then what I would do, and by then I've already been evaluated with the connection going into me, so I know that, and then all I need to do is something like ref val equals my val. Like I think that's basically it. It says can be made const. Okay, this const. It's sort of weird that this worked, but weird C++. But no, how's everybody doing over there on X, on Twitch, on YouTube, on LinkedIn? Oh, I said or woke up. I'm working with Or to do some updating on our development environments. So let's see. Yeah, so the idea is that this thing, forwarding input, is going to be just passing this. And then function call would do something like, it would have something like a vector. Oh, the string with OBS is so confusing. Okay, so this would have something like a vector, or an own vector, because this is yeah, own vector of a forwarding input. I'm not sure I'm allowed to hold this just on the stack. And then I'm going to, here, when map change, that means now map is okay. And then I should be able to do if func equals get function. Then loop over function inputs, right? Function func inputs, and my inputs will be created with a new input. And then once they have, when I call evaluate, so what I would do is, if the function is fine, first I would go through all the inputs and do input my input dot second dot pass, right? No, I need to go over my inputs. Second input dot pass value. That's really what it is. And then and then I need to actually call the function. Return func evaluate. And at this point, evaluates scope. And at this point, this should be correct. Like, because all the pass values is kind of set everything, and then the function should be called. The only problem I'm still not sure about is the API for the connections, because when I did this as a vector, I basically lost my way to connect this without with like a proper variable names. So maybe I'll need like a map here or something that at least lets me do it with text. But you know what? I can just start with just a vector. So I should be so let's say I create this type graph. It's got the type graph has two inputs, x and y, and the call is creating x, y. But create yeah, I think this is good, right? This does not create any specific value. This just creates the inputs. Right? Yeah, this just creates the inputs. So I think this should, right now, this should just, if this builds, this should just return 0. Ooh, what did I forget? Oh, well, let's call it call inputs. Probably better. So that I don't shadow that thing. Call inputs. Call inputs. But still, I had an error. Oh, I need to reference this. No? Create new. What's so input is oh, okay. I think this is what, because this is a map actually. This isn't just a vector. Ooh, did I just get a warning there? No, right? I'm good. Okay. There's a great comment here. I can't show comments on screen, by the way. I'm not because of this thing that I'm doing. So I'm going to read the comments. But there's a great comment from Joseph Lyons saying, "It's been 5 years since I've written C++. I hardly recognize it." It's a comment from Joseph Lyons. Yeah, C++ is new. It's different. I don't. I could write this in the old C++ style, but I don't want to. I mean, I could definitely write this as for int I equals 0, 0 I smaller than, what is this, like local, or how do I call this, self inputs. Give it some name. Just 3 seconds ago, I should remember. Call inputs dot size plus I, and then whatever. But and then whenever I would access it, I would need to, instead of doing just input, I would have to do something like call inputs I dot something. Right? I find that, like, for many of these things to just be way more expressive when you get used to them. I know this is different than what you get taught, but I think like this is closer to how a for loop would look like in JavaScript or modern languages. Like, it's just a for over the container. Like I want to do a function over everything. I don't need to count a number to do this. I feel like this is generally speaking nicer. What else? Okay. So back to my my code here. Yeah. By the way, I'm happy to answer questions about things I'm doing in the language. Like this is not necessarily the most straightforward way to do language things. There's a bunch of my special types in there. Like, just to give you an idea, something you'll see often, I have the scope variable, and this scope variable does a bunch of magic. One of the magic that it does is that it lets you create dynamic types without memory allocations. It does some magic behind the scenes, right? It's a special. It's not a regular C++ type. It has, if you look at it, it's got all these template functions that deal with resources and PMR resources and all kinds of like tricks to make this not just expressive but also fast. So there's a bunch of those, I guess, kind of string together in these calls. Like, there's all these structures that I'm building that are more specific to making this fast. Because one reason why it's built like this, this language is built so that you can run this entire language function in real time. Like, you should be able, for example, to chain your MIDI controller to a few of these values, move your modulation wheel, and have a total new reevaluation of a function. Like, think of that. You move your modulation wheel and you change your pattern from having 1 bar to having 100 bars, and then you kind of make it shorter or closer, or like you can actually mess with stuff like the length of the music. And so it's so there's all these I guess structures in place for you to be able to do that, for the user eventually to be able to do that. Because if I would just implement this naively, the code would look a little bit cleaner, but then it would be slower. Or in some cases, would just click and pop completely when you play it in real time. So this is another hard limitation we're trying to bypass with this. Okay, so here's what I did. So so as I said, I have this forwarding input thing, and now what I need to do, let's see if I have some idea of what I'm doing. So now that I created this, I need to create a function call. So to create a function call, I need to go to my expressions. So like auto call equals expressions dot create of the type expressions function call. And what this should take is really this, but I think what I need is I need the this is not really gonna work, and it's a thing called create expression, which will return to me. I need a way to get the idea of this. You know what? Let's do this, because without it, I'm kind of lost. Let's do, and this would actually help me with a bunch of other things. But I can probably. I just realized I can. This would help, what I'm just going to do will help me simplify other places in the code. I can go to this thing called expression, and I'm already storing the ID in here. Why did I not think about this? Okay, I'm already doing this. No, this is so simple. So now I realize that I can simplify so many places in my code. Okay, so I can just do more. So that's just for simplicity. I'll add another constructor here that takes an expression, and it would just then use the ID. Or I can also, I know, use the other constructor or something. Yeah, and I think this should work. So now I should be able to create a call to this, and this call would have in my call I should be able to do something like 0. Yeah, I'm going to do something hacky, but I still think this should work. So I think I should be able to do something like create val. Oh yeah, so, this is a good question. So there's a question here on my Twitch from Melech Gadol. Hey, Eyal, are you planning to upload Yesh Et HaChalal on Spotify? I love it. Oh, wow. Yeah, sure. I can upload that. Yeah, that's a good song, you know. That's definitely one of my favorite songs I wrote. You know, now that I have one of the nice things that's happening now is that I have my piano here. If you'll be able to see me play piano. But that song is something like, let's open some piano sound. Right, it's that song was something like where does it go? It's a really good song. I'll do like a proper performance or something later, maybe. Yeah, I should probably post on Spotify. I have no idea why that song is not on Spotify. That's very weird. Okay. Okay, so I'm going to. So what I'm back into doing is that I'm trying to create different calls into a function. Even though what I'm doing is like I'm creating the backend into this like music function, and you'll see soon how this creates music, hopefully, and not just lines of code, abstract lines of code. So I'm just going to create something like 5. 7. And then I will run the call. Let's see if this is going to work. I'm not sure this is going to work. Ooh, I knew it not to work. Okay, so this didn't work. Why? Because it went into like some let's see, what are my inputs? Call inputs. Because my inputs were not created. That kind of hints to me that the map was not set. The map on the call map change was somehow not called, or maybe it failed something. Let's see if it got in and failed. So it tries to find. Okay, it went in and tried to find the function. Okay, so there's a question from Melech Gadol on Twitch. What is it? So so what I'm doing is I'm creating a language of sorts. It's not real language. It's gonna be like an actual program, like a program with UI and stuff like that. But it's a music composition program. The idea is that it's a music composition program that lets you specify rules to your music, like repeat this line 3 times, then on the 4th time, make it twice as fast. Then take this whole thing and run it 5 times in different speeds, like stuff like that. Like it lets you run with a very few simple statements. You can create a big piece of music. That's really what it is. It's almost like a programming language for music, but it's not going to be a programming language where you write text like what I do now. It's going to have a nice UI and a nice like visual way to chain blocks together and stuff like that. But it's all going to be about composition. It's all going to be about writing interesting music with specified rules, pre-specified rules that you're adding to this. And specifically, what I'm doing now is I'm defining in my in the backend the concept of a function and a function call. That means that let's say you the user, you define a set of musical rules. Like you say something like, I'm creating a rules for music where it's AABA. These are the rules, right? This is it's almost like a pattern. Like you say, well, AABA is a musical form. And then you're going to pass different musics into this. Like here's this line, make it AABA. Here's this other line, make it AABA. You can make complicated rules, like rules that maybe include randomization. Like here's a musical rule that says play the thing 3 times, but make it crazy in the 4th repeat. This is a rule. Make it random speed, random variation, stuff like that. That's like a nice rule. And then every time you're going to pass new music into this rule, the last repeat is going to be kind of sounding more interesting or weird because you specified this rule. So that's really the overarching thing we're trying to do. Like, how do you, as a user, set all these high-level concepts in your music, all these style definitions that you create in your style, and then you can apply them in different songs or different parts of the song, something like that. Hopefully that was understood. Sorry that I can't show the. I need to think of what's a better way to stream this, but I need a way to show these comments on screen as well. So yeah, so I just want to say, feel free to ask me things in the comments. I will try to explain, reiterate. I know some people are watching this on YouTube or on Twitch or Facebook or LinkedIn. So feel free to let me know. Okay, so back into my ultra nerdy implementation of this. So I just ran into a bug. Here's the bug. The bug is I was trying to find a way to get to the connection, but I think there's a mistake here. Let's see why. So the mistake is when I created this thing called map. Let's see, my map is fine. It's not null pointer, my function ID, it's just a number. Yeah, this thing is definitely not null. It's a weird number, but it's not null. So this should go in. Okay, but it doesn't find this ID. Why doesn't it find this ID? Is it that maybe that I created the function call into different maps? Is that what could have happened here? Oh, okay, that makes sense. I was trying to call the internal multiply function. That's not going to work. I need to call the bigger function. I think this should work better and has lesser chance of crashing, which is a desirable goal in computer science. Not crash. No, it is still crashes. Okay, I'm going to investigate this. Let's see. So I connect this to the right thing. This one is connected under the same map. So in theory, right, I connected the function call into the function. Function inputs. Okay, there's no inputs here. Okay, I see why. So there's no inputs because I never connected those as inputs. So probably what I need to do is connect those as inputs, because that's so interesting. Yeah, because the function itself, when I work on the inputs and I do create, this should connect them, right? You would think. It looks like it's calling connect. Am I calling this? I am calling this. So it looks like I am connecting the input. Yeah, looks like I'm connecting it. It looks correct. It looks like there are inputs there. Why, when I was trying to work with this, when I did this, oh, I know why. Do I know why? Yeah. I think I've made a mistake here. I think I made a mistake. Yeah, because this returns what's called a holder, not the actual inputs of the thing. Yeah, I need to... Yeah, that's annoying, but I think that's what I need to do. I think I need to have another... This is the problem. I have this intermediate type in there called the holder, the expression holder. And I think what happens is this returns me the holder. Not great. Okay. So I would start with, instead of doing inputs directly, I would do... I'm going to do this. I don't love what I'm just about to do. Yeah, I'm going to do this. This is a horrible way to do what I'm doing. Just have a virtual here and then holder. Where's my holder? Yeah, I'm doing something quite horrible. I don't love this. I don't love this. I will change this pretty soon. So this will be something like if expression. No, I think I can assume the expression is not null, so I can just return. Yeah, this is not great. This is a hack, but you know. like this will kind of work, I think. Don't love this. Don't love this. Here you go, 35. Now the main question is, let's add another call, right? Let's do the exact same thing. We'll call this call 2. Call 2 would take different numbers, like 3 and 25. And then I would evaluate both calls. I will evaluate call 1 and then I will evaluate call 2. Let's just directly debug this. So first one with call 1, second one with call 2. Let's see what's going on here. Melech is asking, what is the reasoning behind skipping a bar? Skipping a bar. What do you mean by skipping a bar? What do you mean by a bar in this context? Skipping a bar. Here you go, this works. Yeah, Melech, if you can explain what do you mean by skipping a bar in this context? Yeah, and I think this worked really well. Basically, what I was trying, I mean, I feel like my solution is pretty hacky. I need to do some cleanup now that I've done this because the internals are a mess. Oh, so Melech says, like writing a line, and then instead of writing directly below it, you write a bar lower. Oh, like this. This is really just, you know what, this is a good question. I personally, that's just me with my style. I really like to have clean, separate expressions because it kind of helps me separate in my mind versus doing, you know, this, right? This is, the computer doesn't care. I don't think the computer cares if this, what looks like what, but I like to have some clear, you know, maybe I would do this, you know, maybe, because each one of these 3 statements are kind of together. You can see I'm setting up call 1, setting up stuff to do with call 1, but here I'm setting up stuff with call 2, so it helps me to like have some clear idea of what it is that I'm done versus just staring at a block of text. Especially later when I go back, like, you know, I read some other code, some other pages, and I immediately walk into this and I'm like, oh, something is done here, something is done here, something is done here. Like I don't even know what it is because I didn't have time to read the code just yet, but I have some, you know, I have at least an idea that 3 things are happening. In the real world, you know, I probably would make these into functions, right? And then maybe I don't need to do that. Like maybe I would do something like, you know, void create call 1 or not, and then this would return to me something like a function call, right? Or so I can do something like that. I can do something like function call, create call, something like that with int x, int y, and then I need to get the expressions, which is something like also the expression map. I call the thing expressions, make it easier. And then I should be able to just do, oh, and I also need the function that I'm calling, right? So the function that I'm calling is just an expression, AXPR, something like that. And then I would probably do XY. And then I could make all this, I could do something like autocall equals create call expressions func 5.7, and then the next one would be the same thing with 3.25. It's going to be called call 2, and now I can do those one after the other because those, like, you can see that they're kind of like there's no interconnections there. Everything is in the same line, and I think this should also work. Oh, I forgot return. This is going to crash. Yeah, because I'm not returning anything. So I need to. I wish this would not compile. I have no idea why this lets me compile this. This is so horrible that C++ just lets me compile a function with no return. There you go. So now I can clean this up even better, and I can also let's just do like this. Let's call this create graph, which will take the map. Yeah, and like Melech says, also it's like segmenting. Seems reasonable, especially when you mess up. It's easier to fix the mistakes. Yes, and this is so true. It's hard to explain, what even even if you look at a very, like a super programmer or something like a Linus Torvalds or somebody who's like very good at what they do, or some I don't know. Jonathan Blow, like people who are like very, very elite level programmers, they make a lot of mistakes. Pretty much, like my estimation, is every line I'm writing is going to be, like even when I look at it at the beginning, it looks good. There's probably mistakes there that I don't even notice at first glance. So my thought is always, how am I gonna change this when I realize what horrible thing I've done already? Like it's definitely the computer is completely oblivious to all this stuff. It's all human. But my process is that I'm always reiterating about previous code, about whatever it is that I wrote 10 minutes ago or an hour ago. So yeah, so for example, now what I'll do is that I'll create all this thing, like I'll create all these like nice function with names. Let's call it create function graph. That's a good name. And this would just create this. And it will also add these. So I'll take like every few lines that are connected together, and I will make them one function with a single line. I don't even need to save this. I can just do that. Return func. So now all of this thing is create function graph expressions. These are not needed. And I'll also do something like this. Create multiply func. This is really boring. And this needs to be created inside of the expression, right? So I'm going to need to pass this. I wonder if I can I think I can just pass in just a regular. I can even just press an expression. You know what? Yeah. So I'll need to pass an. Yeah, I'll need to pass the expressions function graph. I think that's all I need, right? Graph. And then this would do these lines. And this would just be graphs. I'll connect to inputs. Yeah, I think this is correct. I think I should be able to do. No? Oh no, this is not the inputs. This is. Oh, how do I know where this connects to? This is connecting to not inputs, but function inputs. Is that true? Is that what it is? I want to take the function inputs. Yeah, because first I created this connection. Yeah, so I should be able to just handle this. No, it is. Oh, yeah, because I need the I/O. So how do I know which expression map was this created on? Oh, okay, okay. I do know. I know how this was created on. I think this is something like this would be inputs X. I think this would be the way to access this, like with the name, right? Yeah, I think this would work. X, this should be Y. So this would be O2. Oh, and I don't even need to reference this. No one needs to look, but I'll just do this anyway. Multiplier equals create multiply, which will take the func. Yeah, so now, okay, this is a little bit better. Now I have more of like higher level expressions, right? So I create the expressions. I'm just gonna change this because this is just an expression map. This is just a map of every expression in my program. Then I create a user function. Let's change this to user function. Then inside that user function, I create a multiply function. This is like in the body of the user function. Then I create two calls to that function, call and call2, each with different arguments. Let's see if that compiled and I didn't screw anything up. There's a warning here. Oh, right. Warning is fine. Oop, I screwed something up. I knew I would screw something up. Why is that? Maybe it's not X and Y. It is X and Y, right? Graph inputs. What did I miss? I knew I was going to miss something. It looks so good. Why didn't it work? I was missing something subtle here in the semantics. Oh, because these aren't the inputs. These are. Yeah, this should be. Yeah, this isn't going to the input. Doesn't make sense. This should be connect to the function inputs, right? Am I wrong? Am I right? Yeah, it needs an expression like this one. Yes, I think that's it. So it's going to be something like func inputs dot map. Expression map. What's the map type here? Is the ID. So how do I find something here by the name? Maybe I need something. I need something that will get me the. Oh, here it is. Okay, so I need something like I need to add this add this operation here. I need to do something that says expression get, which takes a name. Scope. Okay. And this would probably be the same as this. I can probably implement one in terms of the other. I can do that. This would return the element. Return the element. This would return. Do I need to make this const? Is that what it is? No. What is this? This needs to be. Can I convert? Okay. Oh, okay. Return. So confusing. This would return the holder. And Miller says, I think I have better odds learning the Black Page by Frank Zappa than learning how to code. The Black Page is so difficult. The Black Page is like the most difficult piece of music, ever written. It's got like quintuplets over an 11 tuplet. Like it's so bizarre. You, by the way, should take a look because this is going to be like 14 years ago or something by now. Early days of YouTube, I recorded a version of the Black Page that my good friend Doron Giat played on drums. And he learned it from Frank Zappa's original drummer, from Ralph Humphrey, and he has a performance that he does of it. So it's on YouTube. You can look it up. I was like the recording engineer on it, but it's just so much fun because it's like notoriously the most difficult piece to play ever. So I don't know. I think learning the Black Page is more difficult than code. But also, I do have to be honest. This is a very, very, very obscure part of coding, what I'm doing right now. Like it's a very niche thing. Like it's like a language parser or something. It's very complicated. Even though it will make music at the end, I'm hoping. Let me just answer this person who wrote to me. Okay. So just to reiterate for people who have joined in late and stuff like that, what I'm doing is I'm creating a musical composition language. It's implemented in C++, but the meaning is eventually you will have a visual program, and I have a visual program which I will show in a little bit that does a few of these. Visual program that lets you like manipulate sequences of music. That's really what this is about in general. Okay, so what am I doing here? So this is, I just need to return LPTR, and what this would do is this would actually be, this would just return get token not equals null PTR. It's basically one function is going to be implemented in terms of the other function. Okay. Now, where was I? Let's see if I can make this code make sense. This would be something like map get. And this will be the same thing. Get y. Let's pray. Let's all pray. Ooh. Now that's fun. So you're saying it didn't exist. That's basically what you're saying. Right? Expression name. That's kind of weird. What if I do get name instead? No, I'm doing something foul here. What am I doing here? Let's see what happens in these func inputs. Func inputs, they have right, func inputs, map It's got three things in it. One of them is, oh, the name is called A. And what about these other things? Expression. Yeah, that's probably not good. It's called, oh, here we go. One of them is called Y. And the other is called, the other one is the multiply. That's weird. Wait. What's going on here? What's going on? Yeah, maybe those aren't the, I'm not looking at the right things. Because maybe that's not the right name. These are names. Let's see, how did I structure this? So I have this thing called inputs. Inputs has a map. Yeah, I probably need to just, let's just do this. Let's just, no, but you know what? I am connecting this to the inputs. I'm doing expression connect. This should create new inputs. So this should be, oh, okay. I see what's wrong here. It's again the problem that I started with. This creates new inputs on the expression. The expression only knows about inputs. But what I did, I created this thing called an IO. This thing, IO. There, where are you? There you are. An IO is like a combination of an input of an output. So I do need to keep track of this myself. I need to not just create this on the map, which I did. I need to hold a vector or even a map. That would be nice. Even something like map vector of a token and a let's call it IO, right? Okay, or I can just use, I guess, use an expression pointer or something. Expression. And let's call it IOs or something, or I don't know how to call this, connections, right? And then when I create this connection, I also need to do this. Name equals to the address of input. And also when I remove it, I need to do connections, erase, remove, how do I call this? Connections dot remove, that's what I need. I should remove off, I guess the target dot name. Yeah, so remove it by name. I think this should be okay. Hopefully. And then now, instead of doing all of that, I should be able to do func inputs dot expression, connections of X. And this should be the same thing with connections of Y. Let's see if this is anywhere close to making sense. Okay, good. So let's rephrase the high level aspect of what it is that we've done. And then I would probably stop the stream and maybe come on the stream a little bit later. And maybe we can show some actual UI and hopefully something that at least would visualize music. I don't know if it's going to play audio just today. Maybe I'll get to that tomorrow. So what I did was, again, we created this thing that's kind of like a language. It has types, but right now I'm just passing integers, but very soon you will see how it works with music types, with sequence types and types that are much more fun. So so this is just like a high level string of functions that I did to explain what I did. I created first of all, I created what's called an expression map. And a map is just like this data structure that has everything in my, let's call it a preset, or my song. Everything in my song. That would be, I guess, a good way to look at it. I have a song. That song has a bunch of instructions. Some of these instructions are just like music that I would write, but some of them are instructions on how to manipulate that music. I know it's kind of abstract because you don't see or hear any music right now, but you can hope that pretty soon there will be music there. So create a user function. Then I create a multiply function inside of the user function so that the user function itself will do a multiply. In a more musical scenario, this would do something more interesting than a multiply, like sequence together different parts of the music, for example, or randomize a part, or do something more fun than a multiply. But multiply is just an easy function to observe. Then and this is really the part that I was trying to implement right now. I was trying to create two calls, right? Two different calls with two different arguments, and make sure that those are evaluated correctly, so that whenever I evaluated each of those, I would get the result. I actually need to also be able, it's probably something I need to think about, like do a higher level chain, like have another function that passes the value into the call, or something, like chain a bunch of values so that eventually it'll be like the call will kind of be more obscured by the list of calls. And this compiled in the sense that eventually this just called multiply with 5 and 7. I got 35. It called multiply with 3 and 25, and I got 75. So that's correct. It knew how to do a multiply. But it also did it in a way that hopefully in the next stages would be more flexible than just calling multiply. Like this would allow the user to chain a bunch of rules together and do crazier things. So so I think I'm gonna end this one right now, just so I can take a little bit of a break. So thank you everyone for watching on different networks. And I might try a few different ways to stream this. So maybe my next stream would be directly into the networks instead of using this restream thing. Maybe I'll stream directly to like YouTube or directly to Twitch. We'll see. I'll try a few different methods. So thank you so much, and have a good day.